Good morning, everyone. My name is Felienne. I'm on Twitter as well. My Twitter handle is just my first name, very easy. So if you want to share something about my talk, please mention me so I can see what was going on in the room when I was talking. My talk today is about how to teach programming. And if teaching at the university has taught me anything, it is that early morning lectures really need audience participation. So let's go. Who knows who said this? Everyone should learn programming. Anyone knows who said this? Bill Gates. Other guesses? Alan Kay. Nice one. Seymour Papert. Nice, nice. So it's sort of all correct because it's every programmer ever. We all love programming, right? We're all like, oh, programming is the best, so everyone should learn it. But of course, this puts us in a sort of interesting position because many people then actually start to teach programming. So many people that are programmers, they run a code club, or they teach their own children or friends of their children, but how actually to teach programming? Because most people don't really know how to teach programming. So that is the topic of my talk today, how to teach programming. But before we go into this, I'm not an educator, so I want to take you through the story of how I came to think about how to teach programming. And for that, we have to go back to the year 2008, when I started to work on my PhD research at Delft University in the Netherlands. My research was about how to create a DSL, a domain-specific language for finance. So me and my supervisor, we envisioned something like this: a textual programming language in which non-programmers could express themselves so that they didn't need a programmer for anything. So they could create their own little apps and programs to empower themselves to run their own companies in a more efficient or interesting way. Because, of course, there aren't enough programmers to build everything, so it's very good if we can empower users to build their own programs. I started this PhD project with an internship at an insurance company, and in that insurance company there worked many non-programmers. So in my mind, I was like, oh, all those people, they really need my help. They're like, help us, Felienne, we need you. We need your domain-specific language to help us with creating stuff on the computer. But it wasn't anything like that. I was like, hello, can I help you with making programs? And they're like, yeah, we're fine, actually. We don't need your help. We are already programming. All those people, the non-programmers, they were actually already programming within their company. If they needed anything, like a budget or a planning, they didn't need a domain-specific language. They didn't need the IT department. They were just programming it themselves. But they weren't programming in a traditional programming language. They were programming in spreadsheets. The whole insurance company, and I saw many other companies after that, was just ran by spreadsheets. Everyone was building spreadsheets for everything, so they were sort of fine. I went back to my supervisor. I said, I don't think they need a DSL in finance. They have a DSL in finance. It's Excel. It is just an amazing programming language. I really say this without any irony. Spreadsheets are the best programming language that has ever existed in the history of programming languages, really. Thank you. I mean, it is such a good programming language that people don't know they're programming. Let that sink in. Hey, imagine this happening for Java. Hey, I installed Eclipse on my laptop. It was super easy in Windows. And then I opened it up, and I immediately knew what to do, and I built this budget sheet. See how ridiculous this sounds for any programming language. You cannot just jump into a programming language. You cannot even get it to work often. But for Excel, it works like that. You just jump in and start and add some data, and you know what to do because the interface is really intuitive. So my story at that point became spreadsheets are code. Spreadsheets are a programming language. And this is a talk, actually, a similar talk I did at Changeloop a bunch of years ago. So I went on to go to conferences because I really like speaking at conferences. So I went to conferences. I was like, hello, everyone. Spreadsheets are code. I want to share this happy news with all of you. But it wasn't so happy because people would be like, that's not real programming. And I was like, wait. OK, I understand you're a bit skeptic, but I made a Turing machine in spreadsheets using only formulas. This must convince you that it is a programming language, right? This is my Turing machine made with spreadsheet formulas only. So all the rows are different versions of the tape, and the head moves over it with conditional formatting. Super cool. I present to you, spreadsheets are programming languages. Thank you for that, but the people remained unconvinced. They were, yeah, OK, but it's not real programming because it doesn't have this or it doesn't have that, or too many people can use it. And this was a serious argument people used. It cannot be programming because everyone understands it, really. Wait, what? So it sort of went on like this, and after a while, I mean, it really dragged me down. Who in the audience has a PhD or is working on a PhD? Quite a bunch, yeah. So you know this, but I guess other people also understand this, and you and your topic sort of become this one thing. And if people say your topic isn't real or worthy, then you get sadder and sadder and sadder, really. I was at the end of my PhD, I was ready to call it quits with this research. I was just super sad, and it really drags you down if people say your topic isn't important. And at this point in time, I thought, OK, this is just life. Apparently, if adults hang out with each other, they will just call each other's work shit. That's just normal. Little did I know. I thought maybe I should just, toughen up. I should just have a bigger, thicker skin, because people would just be mean to me. It wasn't until way later, in 2015 actually, when I joined a running group, that I figured out that people can be nice to each other. This is what it took, really. So I really like running, and I joined this running group, but I'm not a very quick runner. So my best half marathon is 2 hours, and that's also the world record for the full marathon. So I'm like twice as slow. And there were people in my running group where I did a half marathon in 2 hours, and they do a half marathon in like 1 hour 10. So they were way better than me. But no one in this group said, you're not a real runner. Oh, a half marathon takes you 2 hours. That's not real running. People will never say that. I mean, if you put the shoes on, you're a runner. People wouldn't say things like, oh, you have Adidas shoes, but they have security vulnerabilities. You cannot run on those. No one talks shit about each other's gear. I mean, whatever shoes you wear, you can go barefoot, you can have a shirt or a shirt. It doesn't matter. No one is mean about anything. It's so weird. It's not even that we're inclusive. We're terrible. Is anyone in the audience a runner? A bunch, yeah? So we are terrible. We want everyone to be runners. We almost go door to door like Jehovah's Witnesses. Ding dong, hello, have you heard the happy news about running? It will really change your life, and we will make you such a happier person. We are like that. If I see you running through the bus, I'll be like, oh, do you like running? Do you want to go on a race together? What's your personal record? We are the worst. I mean, we are the best. We are such an inclusive community. Yeah. It is. It's just amazing. And it's not just running. It's also knitting. I really like knitting. I knitted a lot when I was a teenager, and I went to university, and I started to stop knitting. And then I came back to knitting in 2016, and I went to a knitting meetup. However, times had changed in the knitting community. Because when I was a teenager, everyone used these old-fashioned, straight, long needles that you might remember from people knitting in the old days. But now, everyone has circular needles. They're one needle, they're round. So I come to this meetup with my old-fashioned straight needles, and everyone has these circular needles. So I'm like, oh, shit, this is going to be not real knitting. Beep, beep, I want to go home. This will be terrible. But it wasn't like that. They were like, no, of course, it doesn't matter. We can teach you if you want to, but if you don't want to learn and you want to stay with your old-fashioned needles, that's fine, too. Wow. So then I realized that there were other people that were also nice and inclusive, and that it didn't have to be that not real programming vibe. And actually, it's getting even better, because this year, there's someone a talk tomorrow by Lara Schenk. She has a talk about CSS being a programming language. I was like, wow, people are so inclusive in so many communities, like Strange Loop and knitting and running. It can actually be different. So definitely be sure to check out this talk tomorrow. But let's go back to 2013. It's 2013 again. I am sad. I have just graduated my PhD, and I went on a job interview at Delft University, where I also did my PhD. And in that job interview, I blatantly lied about being super excited about spreadsheets because it was such a good research idea to do stuff with spreadsheets, and they fell for the lie, so now I was hired. I had to work on spreadsheets with 2 PhD students and a postdoc, but I wasn't really feeling it. And I mean, it's funny now, but it was actually kind of sad, because on the one hand side, I really wanted to work on this because I still believe it's a very, very valuable thing to work on. But on the other hand, it had worn me out. So I was super, super sad. By a total life-saving coincidence, at this point in time, I ran into a bunch of kids in the community center that needed a programming teacher. So I was like, OK, I will teach children on Saturdays programming, because at least I will be doing something valuable with my life on Saturday. So let's just try and do that, because then, I might not be working on spreadsheets, but at least I'm adding value to the world. But I didn't really know anything about teaching at this point. I hadn't had lots of experience teaching at the university, so I didn't really have a strategy. And what happened then is I sort of started thinking back about how did I learn programming when I was a kid. So this is me. I was about 10 or 11, I think. I had a computer. I taught myself programming. I had these books with basic listings. So for people that are a bit younger than me in the audience, these were books, and they had printed out computer programs in them, like this. So what you would do is you would take this book, and you would manually copy it into the computer. And then it didn't work, of course, because you made many syntax errors. You fixed those. And it still didn't work because you made lots of different errors as well. And then you fixed those. And then you knew programming. Was there no internet? No, there was no internet. There was no YouTube. I got this book from a library. And this is how many people taught themselves programming. So notice the absence of a teacher in this story. No one was actually there to actively teach me programming. I was sort of teaching myself. And by the laughs I got from the audience, I can imagine this is a story that many people my age, children that grew up in the 80s, have experienced. Actually, a recent Stack Overflow survey on about 90,000 developers showed that most people really learned programming when they were very young. 85% of people that filled out this survey had learned programming before the age of 19, so more or less before college. So our whole community is very much a self-taught at a young age community. And that leads to the fact that many people just let children explore once they start teaching programming. They just have the same idea of, oh, you can just give children listings. They will not be in BASIC. They will maybe in Python or Scratch. But the children will really teach themselves. And what I did, I bought a bunch of books, actually, for the kids in my community center. And from those books, you can very much see this vibe of children have to figure it out by themselves. So if you look at these books, the snippets will be in Dutch, but the translation will be underneath in English. So this one, for example, says, the best part of programming is finding mistakes. I don't know. No, don't clap for that. It's stupid. It is not the best part of programming. The best part of programming is building something, right? The best part of programming is that it's a way to express yourself. Maybe the best part of programming is that you get to work at a big tech company and make 100,000 euros a year. There are many things that could be the best part of programming. Why is the best part finding? I hate finding mistakes. I'm like, who wrote this? Oh, it was me. I hate this double. It's terrible. And what about mistakes? Well, programmers only learn from making mistakes. So this sentence is a bit ambiguous in Dutch. It can be people, if there's a mistake, you can only learn from it. Or it could be if the only way you can learn is by making mistakes. But this mistakes apparently is very interesting, and it is a way to learn, or a moment where you can learn. But of course, that also isn't necessarily true, because you can also make a mistake and be like, OK, I quit, I give up. This is too much. But it gets worse. This is a book for kids, right? 10, 11 years. You will fail often, and it will be frustrating. So imagine, like, I'm little Sally, I'm in a bookshop, I'm interested in a new hobby. Maybe horses, horseback riding. Oh, this book, it has pictures of horses. Oh, they're eating carrots. Oh, this is very nice. Maybe let's try something else. Maybe programming. You will fail over me. Never mind. It is, and I'm not saying it's wrong, but anything you learn will be frustrating and you will fail often. Also horseback riding. But most books that are aimed at children are more in the sense saying, oh, this is really nice, and we'll do it together, and we will practice. This is a special thing to say. This says, never be afraid to mess around and experiment. OK, that's not terrible advice. And break the rules. I sort of like this as a life advice, really. But behold, this book is about Python. Same book. This is Python. A space goes there, a colon goes there, a rectangular bracket goes there. This language, for people that don't know, if you put a space in the wrong place, Python will be angry. So, break the rules, but also this is Python. I don't know, mixed messages. So of course, this break the rules thing makes sense, but at a different level. And here's the final one. Most importantly, it's fun. So again, not most importantly, you can build stuff that you really care about, or you can make lots of money. No, the most important thing is having fun. So this is the message we send to young kids. Programming is terrible, break the rules, but also here's Python. You will fail often, and you should have fun. You should like this pain. Welcome to programming. Awesome. So you can really see that all these books, they really radiate this vibe of, you just try it out, you find a mistake, you fix it, it'll be fun. And I did a survey, actually, recently with a colleague in which we sampled 100 code clubs all around the world and asked them about their practices. And we found that 71% of code clubs indeed have students work on their work independently. So each kid works on their own project, and they sort of figure it out for themselves. And the teachers say, oh, we're just there to help. And if they have a question, we can let them know. So this very much is the vibe that we found in these code clubs. And this is very much also how I was teaching when I was teaching in that code club. I was like, hey, kids, here's some books. I'll be in the back, feeling really good about myself, sipping my coffee. If you have a question, let me know. Unsurprisingly, it didn't really work well. The children were kind of frustrated. They were like, whoa, this is really hard. And I was also a bit frustrated, because I was like, well, I explained this to you last week. Why don't you remember this now? It was really quite frustrating, and it wasn't very explicit. It was more subconsciously. I was thinking, yes, but when I was 10, I did all of these things, so why cannot you do this? It was really very hard. And let me remind you that I really didn't know anything about teaching. At this point, I was teaching at a university, so in a sense, I was a qualified teacher, but we have this weird thing in the Netherlands, and I'm sure it's sort of the same in the US, where if you want to teach in elementary school, you go to school for 4 years. If you want to teach in high school, you have to go to school for 5 years to be able to teach in high school. If you want to teach in a university, you just get a PhD in any topic and 12 afternoons of didactic explanations, and then you're good to go. So I was a professional teacher, but I really didn't know anything about teaching. And it was really interesting, because those kids on Saturday inspired me way more to learn about teaching than the kids or the students in the university did. Because what's interesting about an 8-year-old that's not having fun and that is really frustrated is they will tell you. They will take a book and thump it on the table and say, I hate your stupid club and I am never coming back. Undergrads don't typically do that. If they are frustrated, they just go to their dorm and cry. They will not tell you, because, and actually, it's fun, but there's also a serious point that undergrads will have this self-image of that they're really smart because they're in university, and then that they should be able to understand everything. And I have done some terrible teaching in university, and I know other people have. So sometimes it isn't about the student, it is about the teacher. But you do not get that feedback because often students that are older think it's about them. So I was very, very inspired by these Saturday kids to learn about teaching. And one of the things I read is the Oxford Handbook of Reading. And this is really, really an amazing book that summarizes for lay people, for not people that are linguistics researchers, how children acquire reading skills. And the first thing that I got from this book is like, wow, we know nothing. We programming, we have no clue about how people learn. Those people in linguistics research, they know everything. Like, let me just take you through one of the research findings I read about in the Oxford Handbook of Reading, is that how words sound really matters for your reading ability. So let's do another mandatory audience participation moment, because you have to be waking up maybe. So let's do an experiment. What we're going to do is I'm going to show you a sentence on the screen. You will read the sentence in silence, and once you've reached the end of the sentence, you raise your hand. So, a sentence. Perfect. There's one caveat, though. I will show the sentence to you in 2 steps. So rather than at once, first you get the first part, then you get the second part, and once you've read to the end of the sentence, then you raise your hand. Yes? Are you ready to go? Perfect. I have another one for you. Yeah, so what happens there is you read, I have a tear. And then it says, in my pants, and then what you do in your brain, you have to go back. You have to re-pronounce the sentence in your brain, saying, oh no, it's not a tear, it's a tear. They've done lots of experiments like this, and this proves that even for adult, proficient readers, the sound of words really matters. We know, of course, that this matters for kids. If they're starting to read, then they sound out all the letters, but this effect remains if you're an adult reader. They know all of these things, and they've replicated this in Chinese and Japanese and Italian and English and Dutch. There's so much research on this. I was like, wow, we really know nothing. But the second thing I got from these books is that we lack fights. Not really, we have enough fights in programming, but what we lack is pedagogical diversity. There are not different beliefs in our community about how to teach. In language, there are different schools of thought about how to teach language. You might be aware of this difference between the phonics approach and the whole language approach. So the phonics approach is where you really deliberately sound out letters. I, d, read. Often these movements are also made by children. C-A-T, cat, k-at, cat. This is how you spell out languages. So the people in phonics say you should really first acquire all the letters, and then the words, and then the sentences, and this is how you build up knowledge. On the other end of the spectrum, you have the whole language approach. And the whole language approach says, no, reading is not a technical skill. Reading is communication and really belonging to a community of readers. Everyone reads. So instead of focusing on technical skills, you should just have children write stuff. So the most extreme version of this gives children a pencil and says, just write something. So they're like, oh, what does it say? And the child says, a unicorn lives in the forest. Of course, it doesn't say that, but they're practicing motor skills, and then slowly they will evolve towards our alphabet, because it's slightly impractical if everyone has their own alphabet. But the whole language people say, this way you gather the enthusiasm and the natural instinct of children that want to write, so this is how you do it. You in the US might be very familiar with something called the math wars, which is a very, very similar debate, but in mathematics. So one side of the argument says, If you want children to be able to do math, you should just explain them how it works, and then they practice a lot. First addition, and then subtraction, and then multiplication, and you build up skills. The other side of the argument says, no, no, mathematics is not about boring rote practice. Mathematics is about building beautiful proofs. So you want to have children explore the mathematical world and the math that is in everything. And then you want them to solve problems. So that's the other side. That's very much like the whole language approach. And that made me wonder, why don't we have that debate in programming? Why don't we have these two streams of what people think is the best way? So that probably has to do with the history of teaching programming. So I already heard the name of the creator of Logo. It was suggested as one of the people that suggested that everyone should learn programming. So Logo was one of the first programming languages for children, and it was created by Seymour Papert. This is someone that many people know. But what many people don't know is Papert, who was a mathematician, actually studied with one of the most famous psychologists of the previous century called Jean Piaget. And Jean Piaget was the founder of constructivism. And the basic idea of constructivism, I mean, of course, it's a very broad philosophy, but the basic idea is everyone constructs their own knowledge. So it is impossible for me to put knowledge in your brain, because you have to construct your own knowledge. And what Piaget said about Papert is he said, nobody understands my work better than Seymour Papert. So the history of programming languages for children was very much influenced by this constructivist view. And Seymour Papert is known to have said stuff like this. By explaining something, you take away the opportunity for a child to discover it. So this very much says, do not explain stuff to children. And this is the vibe you see in all those books. So it's not just about we in the 80s not having access to teachers. It's also ingrained into the being of programming education that you shouldn't explain stuff to kids. And this might make sense, but it makes less sense if you look at teaching other things, specifically things outside of the school context. So imagine you have a kid and they want to learn the guitar. So you buy them a guitar. It's like, hello, Barbara, congratulations with your birthday. Here's a guitar. Thank you, Mommy. What do I do with this? I don't know, kid. You just figure it out by yourself. It will be fun. I don't want to spoil the surprise for you. It's kind of weird, right? Or you have a kid that wants to do a sport, wants to play tennis. Congratulations, Tom. Here's a tennis racket and a ball, or 5. I will not tell you how it works. That is no fun. You should discover this. So for all these things that are not school topics, we are all, I guess, kind of convinced that lots of practice makes sense. If you want to be really good at a sport, you need lots of practice. And also deliberate practice. So if you do soccer, you will not only do soccer matches all the time. You will practice, kicking the ball and running, and I don't know, soccer, something with balls and running, probably. But you will not do a soccer match all the time. You will not practice the real thing. You'll practice small things. And the same with practicing the guitar. You will not just do this one song you like. You'll do finger placements and chords. You'll practice tiny things. Notice how these things in outside of school contexts very much look like this side of the argument. Very much looks like deliberate explanation and deliberate practice. So for out-of-school topics, we all sort of agree with this side of the argument. Beware. Controversy ahead. If you are easily offended, you might want to leave the room now. Don't complain later, because I've warned you. If you gather all these types of philosophies, exploration on one side and explanation on the other side, it just turns out explaining stuff to children actually works really well. There's this paper by a Dutch psychologist, and the title is sort of a spoiler. It's called Why Minimal Guidance Doesn't Work. You can read the rest of the paper. You can easily find it on the internet. It's actually a very interesting paper, but the title really says it all. This is a meta-study, so they have studied studies, and they explain all sorts of studies that explain quite well that explaining kids really works. So in this paper, they talk about this paper that I really very much like. It's called The Use of Worked Examples in Problem Solving by a researcher called John Sweller. So what has this researcher done? There were two groups of children, and they had to solve an algebra equation. Something like this: you have a is 7 minus 4a, solve this for a. Pretty traditional puzzle. One group of children just did it like this. The other group of children, they gave them a recipe. So it just said, if you have a problem that looks like this, hey, what you can do is you can move the C times A to the other side. And what you can do then is you can get the A out, and then you can divide. And this is how you solve the problem. And then they got the same algebra equations as the first group. So they got the equations plus how to do it. Unsurprisingly, I think, this group with the recipe did way better because they got the recipe. But they did spectacularly better. They solved the problems in 1/5 of the time as the other group, so really quite quicker. But the interesting thing is that also on new, different problems, they did way better. And this is, of course, what people typically have against this type of instruction. They say, yeah, but if you tell children how to do it, of course it will be easy. But this also carried over to new problems. And in order to understand why it actually worked like this, we have to do another, I'm sad to say this, mandatory audience participation moment. But I'm going to sweeten the deal a bit for you, because I will bet some money. So I'm going to show you a sentence, very brief sentence, for, let's say, 1 second. If you can reproduce this sentence, I will give you $1,000. Are you ready? Any takers? OK, I'll do another one. I'll make it slightly easier for you. Another sentence. This one is easier, so I will bet $100. And do not make pictures, because that does not count. Ready? Any takers? OK, I'll do another one, but this is not for money, because you will definitely get this one. Same length sentence. I'll show it same amount of time, but I'm sure you'll get it. Haha. So why? Each sentence is equally long. How is it that this final one is super easy? It is actually because our short-term memory is very, very limited. Your short-term memory can only hold 7 plus or minus 2 items. So between 5 and 9 items fit in your short-term memory at the same time. This is old research from the 50s. More recent research actually suggests that it might be between 2 and 6 items. So very, very, very small short-term memory. It is a miracle that I can stand here while speaking and wave my arms if I have such tiny working memory. How is this possible? Well, this is possible because your brain can do a thing that's called chunking. So rather than saving individual letters or individual characters, in this situation, you store just 3 things, because you see the words, oh, cat loves cake. And then there's 3 things in your working memory, so there's even room left. You can think, oh, cats, I love cats, I miss my cat at home. Or you can think, oh, cake, maybe there's cake in the coffee break, I love cake. So you have these 3 things, and you have room left to think about these things while also remembering the things. And that's because you've done a thing called chunking. You've made it smaller in your brain, and that way it can process really easily. If I would really have bet $1,000 with you, and you were actually trying to remember this, what happens is you feel your working memory get overloaded, right? You really want to remember this. Oh, it's a circle with a dot and a stick and a sigma reverse, and there's diamonds and a big C. It doesn't fit in your brain. You experience this fullness almost, and that fullness is called cognitive load. So once your working memory is too full, you experience cognitive load. And this helps us understand why this first group did so much better than the second group, because in the second group, the cognitive load was too high. So what happened is the children were solving the problems. They succeeded in solving them, but there was no cognitive load room left in their brain to actually remember and reflect what they were doing. So they didn't memorize everything after having solved the problems. And the biggest thing, I think, to take away from Kirchner's and Sweller's work is you don't become an expert by doing expert things. Like with the soccer example. You don't practice a soccer match. If you're training for a marathon, you don't do a marathon every day. That's a terrible idea. But for problem solving, it makes so much sense. And I've heard many people in different contexts say this very often. Yeah, but I want children to be problem solvers. So they should solve problems. But sadly, it doesn't work like that. If you want children to be good problem solvers, you need to make sure they have enough problem-solving chunks in their brain that they can rely on. So my big strategy, my research plan, is to start a fight. I mean, a nice fight, a pedagogical debate, because I want to talk about these two sides of programming education, because that side has been overemphasized, partly because of the involvement and the historical background of Seymour Papert. Everyone is talking about this type of teaching in programming. So I want to talk about this type of teaching. How would direct instruction look like for programming? What could we do if we're really focused on explaining children, students, the basics of programming and make sure that they practice a lot in the right way? So one of the researches I've done in this direction that I am very, very excited about is we've been experimenting with having children read source code aloud. Remember this. Remember how much it matters how something sounds in your brain for you to interpret the meaning. We asked a bunch of children to read some Python aloud. Just a snippet like this. X equals signs 5. What do you think this says, children? X is 5. X equals 5. X gets 5. Set x to 5. Assign 5 to x. It all makes sense, but there's no consistent model for how people say this. The interesting thing about this study is we didn't do it with random kids, we did it with Dutch kids. And we didn't really anticipate, I mean, Dutch kids are in my country, so we didn't really anticipate this would have an effect. But a very, very, very interesting thing happened that we didn't think of. This letter, in English, of course, is the I, as in tie. In Dutch, my native language, it is not pronounced I, it is pronounced I, as in creep. So we had kids that read this code snippet as follows. They said, for I in range, print I. Within the same code snippet. And that, of course, raises the question, do they really, in their subconscious mind, have realized it's the same variable? Probably, to your term, probably they haven't really got it connected well that it's the same variable. So this is something we should explore, and it makes sense to say it like this, because these were 12-year-olds. Dutch 12-year-olds know some English. So for the first sentence, their brain goes into English mode. For I in range. But then for the next one, they're like, oh, so what does it do with the I? Detailed reading, print I. So it makes sense that you have these two modes of reading if you're a Dutch kid, but it will hamper the readability of source code if you don't explicitly practice this. So we actually did a study in which we told children how to read code aloud. So really, in a classroom setting, repeat this after me, children. For I in range, round open bracket, for round closing bracket, colon. We really had them practice the syntax aloud. And this works. So the group that read code aloud every week did better on a syntax test after this course. So they were better able to remember syntax. And this is the paper if you want to read the paper. Now everyone is angry with me. So my life has not really gotten any better, because people in programming are really upset about this. The first time we submitted this paper, it was actually rejected, and one of the reviewers said, this paper doesn't make sense because programming is not about syntax. So what is it about, reviewer 2? I don't know. So, and again, this is this different level. This is break the rules, and this is Python. Of course, programming is not about syntax, but also it is, because you need syntax to be able to make anything. But how upset programming is nothing compared to how upset elementary school teachers are with this result. If I go to teaching conferences and I talk about this, they're like, OK, lady, so it is 2019. And you people in programming, you have figured out that making children read stuff aloud actually helps their understanding of things. Slow clap. We are so impressed. Thank you for this amazing work, Dr. Hermans. They know this in education. They know it really, really well. We are the fools here. They know this. Like, not even just for reading language, but also for math. Like, how do you learn the tables of multiplication? 1 times 4 is 4. 2 times 4 is 8. How often have you practiced that? Hundreds of times. It just makes so much sense. But as far as we know, we are the first ones to actually have explored this for programming syntax with unsurprising results. So that is a thing that works. Another thing, revolutionary idea, is you can actually tell students how to solve problems. That also works really well. I found this amazing paper from 1992. Some people in the audience might have not been born. So it is very old. And this paper is called The Case for Case Studies in Pascal. It's also easy to find on the internet if you want to check it out. What did they do in this study? These were high school children. They had 3 groups. The first group of children wrote their own code as a solution to a problem. And then, after they've written the code, they got the solution that an expert would write as an inspiration to learn from. First group. Second group, same setup almost. They wrote their own code. Then they got expert code to read, but also they got an explanation. So next to the code they were reading, an expert would have said, well, here I use a for loop, and then I use a variable. This is the steps that I take, and this is why. Then there was also a third group. They did not write any code in the entire class. The only thing they did is they studied expert code with accompanying explanation of how you create code. So these are the 3 groups. Write and read code plus an explanation, just reading code plus an explanation. The teachers very much preferred, these were programming teachers, the first condition. They said, first they have to solve the problem, and maybe then we give them the code, but not the explanation. But who actually did better? The second and the third group did equally well. So the group writing the code and reading code plus explanation did as good as the group that was just reading code plus an explanation, and the first group did worse. And this makes sense from that cognitive load perspective. Reading expert code with an explanation doesn't cost you very much cognitive load. You can just read the code and then, oh, why has this person done this? Oh, there's an explanation right there. I can read it immediately. So there's lots of cognitive load left to store problem-solving chunks, to remember, oh, if I have to reverse an array, this is the steps that I would take. I can remember those. They will come in handy in the test. So those 2 groups didn't even have a difference. They did equally well. So you might as well not have your students write any code, because it doesn't make a difference. That is spectacular, given how we currently teach in university and in code clubs. Do not have children programming. Have them read code and explain them how the code works. So explicitly teaching strategies really, really works well. A third thing that we're currently exploring is assessment, and then specifically assessment in these code club situations. Because in the same survey I did with my colleague that I talked about earlier, we looked at assessment, and only 23% of code clubs use any form of assessment. So it doesn't have to be assessment like you get an A for programming, but just assessment in the sense that the teacher has an idea of what children have understood. So we do these tiny things now in our code club, tiny tests. Which one is a variable? Circle it. You want to set the variable points to 0. Which one does that? you can do this in 2 or 3 minutes at the end of your club. Just hand out a sheet, circle all the things, and then you'll get an understanding of what kids have memorized. And there's also research suggesting that if you ask people to remember something, that will actually strengthen their memory. So having children remember this will increase their ability to recall it in the next week. Plus, you'll also get an insight of what they know. However, of course, here too, there are haters. Because haters are everywhere, except for running and knitting. So people, if I do this talk, I've done this talk a bunch of times at programming conferences, and what happens is people come up to me. At this one conference, a person came up to me. This was a guy, they're often guys, comes very close, points his finger at me, very close to my nose, says, "You're making it look like school!" Is that a bad thing? I mean, school, I know there are issues with school, but in general, school is pretty successful. Most people can read in most countries where there's education for most children, so I don't know. It's not terrible. And this anti-school is also part of our programming culture. Right? We have all these dropouts that are very famous that say, oh, you don't go to university, you can just work at a tech company. So against school also fits the whole philosophy of this exploration. So people say, hey, it's not fun. Programming should be fun, remember from the books. But I have science. It actually doesn't matter. This might be the second most important takeaway of my talk. It doesn't matter if people are having fun for learning. I go to this running group every week. So I go to this running group. Hello, welcome to running class. We will do 50 push-ups. Not fun. You know what's fun? Lying on my couch, watching Netflix, and eating potato chips. Fun! 50 push-ups, not fun! So why do I do this? Because I know it will make me stronger. It will make me quicker. The same is true for learning. Children know that learning is no fun. Children already, when they come into elementary school, have learned to walk, and they fell all the time. Not fun. Still, they went through it. They may have learned to ride a bike. They fell all the time. Not fun. Everyone knows that learning isn't necessarily fun. Learning is hard work. But still, adults think that motivation somehow leads to skill, that if children are having fun and they really want to learn, that they will learn. This is not true. There is a relation, but it actually more goes the other way around. If children are learning, if they are acquiring skill, they will be motivated. I did the 50 push-ups. Hey, I broke my personal record. Yes, this is working. I will do more. Children know this. So this whole learning should be fun, we should probably stop saying it, because it's very much about realizing you're learning, realizing you're advancing, and that will bring the motivation and not the other way around. So that's more or less everything I wanted to share with you, but let me take this opportunity to summarize my talk in like 2 minutes I have left, because some people came in late and it's early and you might be jet lagged. So let me give you a second chance to get the gist of this whole talk. First of all, don't be these people. Do not be these people. Don't say, this is not real programming, because it's not necessary. We should be like runners. Everyone should like programming, and everyone should be a programmer. So please, don't be these people, and don't allow these people in too much. However, before you do that, I'm actually, together with Lara, the CSS algorithms lady, I'm running a little online survey. So for once, before you never do it again anymore, we would actually like your opinion on how you see programming languages on the spectrum of least to most programming. So we made this web app where you can put your languages. You can do this in secret, and no one looks at you while you're doing it, because if we want to battle this together, we should also understand what is seen as most and least programming. And we have this open text box also, because we want to understand, why do you think that? Is it about testing type systems, syntax? We want to understand this culture, because understanding it will be a more effective way to change it than me saying, don't be like that. So please, don't say it, but fill out our survey. This is a link. I will also have it at all the way at the end of my talk, the same link, so you don't need to do it right now. I will show it at the end as well. It will be very helpful for us if you share this link, if you fill it out, because we want to get this, understand this vibe of what the community believes about programming. So this talk was about how to teach programming, because I tried it in a bad way, and it was not very enjoyable for me or the kids, mainly because I was thinking of how I learned programming, which is how many people learn programming, and that was without a teacher. And this culture of not having a teacher is very visible in programming books and online materials that all say, just have some fun. Probably this is also amplified by the history of programming education, because the creator of programming education for children very much believed that explaining was a bad thing. But now we know that explaining actually is a good thing, and there's ample research in all sorts of fields showing that if you want children to understand stuff, you should explain them. And this is what we are exploring now in my research group, where we're looking into having children read aloud, explicitly teaching them how to solve problems, and explicitly using assessment also in out-of-school programs. The end. If you'd like to see more of my work, including all the papers that I've written, they're on my website, felienne.com, and I'm on Twitter. I will also be here today and tomorrow, so if you want to reach out to me, just chat. I'll be available in the hallway. If you enjoyed listening to me, you might also enjoy listening to my podcast called SE Radio, where we have shows with other hosts every 2 weeks about all sorts of software engineering and programming topics, SE Radio. One question I'll answer, we're not doing Q&A because there's no time, but I always get this question where people say, have you made those slides by hand? Yes. On the iPad, though, I use an app called GoodNotes. On the iPad, I have drawn all of these slides. And I'm very proud of my drawing skill, so yes, I have. And then here again is the link to the website we would very much like you to fill out and spread on the internet, bit.ly/pl-views. We'll be very, very happy to see your results come in. The end. Enjoy the rest of Shane's Loop. Thank you very much.